All right, 7.4, powers and roots of complex numbers. So today's lesson is going to talk to you about De Moravian's theory, and then there's some other different theories from that. I'll give them to you, and then we're going to work on solving a couple problems, all right? So you should have gotten my PowerPoints on this, so that will help. You don't have to be crazy taking down notes. All right, so it would look like this. Starts from our sine theta, I sine theta, all right? And then it has our n to the nth power, and we'll go over this. So basically what it's saying is we have our information, r cosine theta minus I sine theta to the nth power. So if you have that, here's what you will end up with. R to the nth power, okay, r to the nth times cosine n theta plus I sine n theta, sorry, all times, or r to the nth power, CIS, n times your CIS, all right? So basically this is essentially, it's the same thing as what we've been talking about. It's just giving you an information so you know what it looks like. So, good example. The first problem they give you is minus 1 plus I to the fourth power. So there's our problem. So we start with what? In order to convert this, if we want to find this and we want to using this guy's theorem, De Moravian's theorem, how would we solve this? So we would first solve simply by finding what our r is and what our theta is. So we got to find our r and our theta. So first off, what's my r? My r is going to be what? 1 squared plus 1, right? Squared, right? So r equals square root of 2, correct? So we have our r. Questions so far? Are we good there? Next, we need our theta. So what's our theta going to be? Theta equals tangent negative 1, positive 1 over a negative 1. So either way, still going to be 1 over 1. So if you look at your chart, right? If you look at your little chart, your unit circle, what's it going to be? Tangent negative 1 is equals, theta is going to be 3/4 pi, okay? So we have our r, we have our theta. Any questions on our r and our theta? No questions yet? So now we plug in to this information. So you can't do any of this until you find your theta, your r, and your theta. So we found those first, then we plug in. So if we were to plug it in to our simplest form, obviously let's always go with the simplest form. So our r is square root of 2 to the fourth power, right? Because n is our fourth power. CIS, n, 4, and 3/4 pi. Any questions on that information? All I did was take the information we have, which is our r, our theta, and our n, and plugged it in to this initial equation that we just learned, De Moravian's theorem. So, what am I left with? 2 to the fourth power is really 4, CIS, theta, or pi. So that would be our final answer that we're looking for. I'm sorry, time out. 3 pi, right? Okay, now, if it says to you express it in between 0 and 2 pi, that's important because that's only on one unit circle. What would that really be? Another way to rewrite that is 4 CIS pi, okay? All right, because basically what is it saying is you went around once and went around to here, and that's where it would be, okay? So there's our final answer. Now, my question to you is, how do we know if this worked? Well, the way you can solve this is by plugging this in right here. you can solve this back and see if you get n, just n. So how would we do that? 4 cosine, so this becomes cosine pi, right? Minus I sine pi. What does this become? -1, right? Minus 0 times 4. What does that give me? -4 or a +4. Correct? Everybody agree with me? Gives me a -4, right? And that would be essentially what your 4 is essentially, and shows that information, okay? That's how you can change the answer back to rectangular form, and you'll solve and see that it actually works wonders that way, all right? Any questions on how to solve this? So, start with your complex number with your root out here. You have to solve for your r, you have to solve for your theta. Then you can go in and plug it in to your de Moravian theorems that they gave you, all right? Now they give you 2 other theorems that you'll want to put on a note card. Or not theorems, but equations to solve for, okay? Because they could come and show up in different methods. So another way it would look is r cosine theta plus I sine theta 1/n. 1 over n. So if it's 1 over n, then what would it be? So remember, the other one was with n, okay? It just had n there. Now it's 1 over n. So what would it look like? Square root of n, okay? Square root of r, theta. Now instead of cosine it being n times, it's going to be n divided by ni theta over, got the sign, over n. All right? Any questions on that? All right? So if your complex number looks like this, 1 plus I, and they give you a 1/2, essentially you can use this equation right here. Okay? That's the idea. All right? So then the third equation they give you is if the equation has an n here, r cosine theta plus I sine theta. If that's there, what's another way to rewrite it? Okay, here's what they would do. Obviously, n, r, right? Theta. Now, cosine, so our cosine is going to be theta plus 2k pi over n plus I sine, and the same thing, over n, all right? So if it has an equation, so these are the 3 different ones you're going to look for. If it's going to be a 1 plus I, and it has a number up here, then it's this one. If it has a fraction up here, it's this one. Okay, so if it's a whole number, fraction, oops, can't spell, fraction, and this one, of course, is if it's a square root. All right? Okay, so those are the 3 types of equations you're going to use, and all you have to do is practice in those veins, all right? So let's do another practice one. So you have those 3 equations down. All right, so once again, here's our information we've learned in this chapter, starting from here down to here. And in this section, 7.4, you learned these 3. I'm not going to quiz you on them. You're not going to have to fill in the blank on this or anything. You will have to use them, so you need to have them on a note card somewhere so you can practice using them. All right, so here's a good example. All right, I to the 3rd power. So what's another way of rewriting this equation? I to the 1/3. Good, it's another way to write it, correct? So what do we have to do first in order to solve this? We can't use these equations till we find what? We need 2 things we need to find. We need to find our r, and we need to find our You need to find the r and you need to find the theta. So here we go, ready? So first off, r equals square root of a squared plus b squared. Well, what's your a? Well, there isn't an a. Very good. 0 plus 1, right? So r equals the square root of 1, which is 1. Everybody got that? So we're good so far? So we found our r. Now our theta. Tangent, -1. B, which is 1 over 0. So class, 1 over 0 is undefined. So tangent's undefined. When on the unit circles, tangent undefined. 1 over 0. When is tangent 1 over 0 on your unit circle? Right here. 1 and 0, right? So therefore theta equals pi over 2. So once we have those, now what do? Now we can use one of these. Which one of these will we use? Which one of these should we use? I to the 1/3, right? Let's do this one, right? It'll be the easiest. So what do we got? So it's going to be what? 1. All right, 1 CSI pi over 2 all to the what? 1/3 power, right? The whole thing to that. If we do that, we're left with 1. 1 to the 1/3 power is really just still 1. And 1/3 pi half over 3, which essentially is CIS pi over 6. So if I were to say to you, I want you to solve for the complex number, what would the complex number be? How would I find what the complex number is? All right, so any questions on finding the principal cubed root? We're good with that so far, right? Any questions? So we have the first one. We have the principal one, which is cosecant pi over 6, right? Right, so once you find one of them, then what happens next, if you look at the book 366, they're gonna try to get you to find all of your possible functions that way. They're the 3 possible functions. All right, so what would those 3 possible functions be? All right, okay, so how would you find your 3 possible functions? So you find them by adding 2 pi to the angle, okay? So when we add 2 pi to the angle and 4 pi to the angle. So the first one is very simple, it's straightforward, okay? All right, we know what that is. How would we find it? We would take this and we plug it in. So we have cis pi over 6. So once we get there, once we get here, now we need that complex number of that. Well, what's that going to be? Cosine pi over 6 plus I sine pi over 6. So what is cosine pi over 6? Cosine pi over 6 is going to give you square root of 3 over 2 plus pi over 6 is 1/2, right? So it's going to be 1/2 I. So that's your first set of complex numbers. Then, how do you find the next one? Well, it's another full rotation, 2 pi. So, what do? As opposed to using just pi over 2, all right, as just opposed to doing pi over 2, you have to do pi over 2 pi. So adding 2 pi to it. So if you add 2 pi and then you add 2 pi more, what's that going to be? What's that full rotation going to be? So your first one was CIS pi over 6, right? Our next one is you have to go back to the initial work, which is this one right here. This is our initial thing. So you're going to go back to your tangent, your theta that you solved for, and you're going to add 2 pi, and then you're going to add 4 pi. And you're going to plug it in to your CIS equation. So this is a little bit more difficult kind of problem. So I'm going to erase our R because we don't need that anymore because we know it's 1. So what you do is this is your first one. Our second one is going to be when we add 2 pi in it. So therefore it's going to be 1 CIS pi over 2 plus 2 pi all over 3, right? Okay, because it's to the 1/3 power, right? So there's your answer. When I simplify this, I'm left with what? CIS to the what? Well, it's going to give me 2, right? So it's going to be 5 pi over 2 over 3, right? So what's that going to equal out to? CIS 5 pi over 6. So then once I find this, now I can go cosine 5 pi over 6 plus I sine pi 5 pi over 6. Well, what's that going to be? Cosine 5 pi over 6 is negative square root of 3 over 2 plus 1/2 again, right? Right, so 1/2 I, correct? So we have 2 answers, correct? So our third one is we got to add 4 to it. So the third one's 4. So it's going to be 1 CIS pi over 2 plus 4 pi, which is really 8 pi over 2, right? So that's going to be over 3. So it's going to be CIS 9 pi over 3. Oops, 9 pi over 6, I'm sorry. 9 pi over 6, okay, because you bring the 3 up. Well, what's that reduced to? All right, essentially that reduces to, well, cosine 3 pi over 2 plus I sine 3 pi over 2. Cosine 3 pi over 2 on your unit circle is 0. And this is going to be I and -1. So your final answer is -I. So you have 3 answers. Your 3 answers for your pi, for your first initial answer, for your 2 pi answer, and then your 3 pi answer. Okay, or 4 pi answer, as it goes around 4 times. These are the 3 distinct cubed roots, because there's, to the 3rd power, there are cubed roots. All right? If it's to the 5th power, whatever the n is, that's the root power. That's how many times you would have to go around and find it. All right? Any questions on that type of problem? I know this is going to be very difficult for you. It's very time consuming and tedious, but you can solve those problems. I know you can, and we'll go from there. All right? All right, the last type of problem, the last example that we will do today is when they give you this problem in this manner, this way. All right. Okay, when they give you the problem, it looks like this. 5 okay, so here's our problem. See, do you see what that one looks like? Yeah, right here, good. Looks like this one, but they already gave you the 5, so what happens? 32 goes to what? Goes in this to the 5th power, right? Which, by the way, can we solve that very quickly? The answer is what? 2. Good. And then 5 goes underneath here, right? So it's going to be CIS to the 10, right? Because 50 divided by 5 is 10. So what's the next one? If I were going to do a root all the way around, how would I do this very quickly? So think about this for a second. How many degrees does a circle have? 360. And it's going around at what root? 5. Divide by 5. What do I get? 72. So our next one is going to be 2 CIS 82, 2 CIS 154, right? Add 72 again, 2 CIS 226, and 2 CIS 298. Makes sense? And so you have 5 roots. Your 5 roots are 10, 82, 154, 226, 298. All right? All right, this is the end of lesson 7.4. Longest lesson of the day.